Alright guys, this is our last lesson for this week. We're going to do a quizzes tomorrow just to kind of check in and see how you're doing with all the matrix stuff we covered this week. So 2 topics today. One is determinant, the other is inverse. So determinant is just a number we get from a matrix. It's a special number that we use for different things in math, but it's just going to be a number. So to get the determinant of this first example, it's always going to be a process of multiplying and subtracting. You always start with the first diagonal. You'll do A times D. You do the product of the first diagonal. And then it's minus, we do the product of the second diagonal, minus B times C. And then that's just going to give you a number, which is what the determinant is asking for. So if you look at number 1, we want to find the determinant. We're just going to do first diagonal, would be negative 2 times 3, which is negative 6. And then it's minus, do make sure you always have the minus there, the second diagonal is 4. So you should get an answer of negative 10. Because it's minus, it is important that you're doing this in the correct order. If you do it in the other order, you get a positive answer. So just make sure you're careful about the order that you're subtracting in. So number 2, if I do first diagonal, I get 4. And then it's minus the second diagonal is negative 15. Because it's minus a negative, you should change that to plus a positive, and you should get an answer of 19. Okay? Hopefully not too bad. The second concept for today is what's called an inverse. So first off, we have notation. You guys have seen this before when we did trig stuff, when we did functions. When you put that negative 1 attached to it, we read that as the inverse of matrix A. To be the inverse by definition, it means that when you multiply A times its inverse, that they cancel out and we get what we call I. I refers to the identity matrix, which you'll find over here, which isn't just like 1 or 0, but it's a combination of 1s and 0s. It's always a diagonal of 1s going from the top down, and everything else in the matrix is 0. Notice it also says that if you do the other order, if you commute it and you do the multiplication in the other order, that also should give you the inverse. So when we test these, we do kind of look to see if it works both ways to make sure that they really are inverses. So that's what our first question is. They gave us 2 matrices. We want to know if they're inverses. So to test that, the definition says that if they're inverses, if we multiply them, they should, in essence, cancel each other out, which means we get the identity. So we're just going to multiply them. That's all you have to do here. That's all we're doing. We're multiplying them. So if I multiply, just like we did in the last lesson, this is a 2 by 2 times a 2 by 2. So I'm going to end up with a 2 by 2. And then it's going to be first row times first column. That's going to be negative 4 plus 5. And then first row times second column goes here, negative 2 plus 2. Then we can do second row first column. That goes here, 10 plus negative 10. And then we do the last one. That's going to be 5 plus negative 4. Then we're just going to simplify that down. That's 1, 0, 0, 1, which tells us that because that worked, that is an inverse. If you want to check the other way, you can, but I'm just going to go ahead right off the bat and say yes, they are inverses because they do cancel each other out. It is unique that it does work both ways, because usually, remember from yesterday's lesson, if you multiply in the other order, you get a completely different answer. This is the only case where if you multiply in the other order, you get the same answer. All right, then the other big part of today is how do you find an inverse? So I'm going to give you a matrix. I want you to create the matrix that would actually cancel it out. And that's what this top formula is telling you about. It's how you find the inverse. So this is the important formula. It has 2 parts to it. You have to find the determinant, and then we always do 1 over the determinant. And then what's happening here, if we look at the diagonals in comparison to the original diagonal, the first diagonal switches the elements. The A and the D switch spots in comparison to this original. And then the second diagonal, if we compare those guys, these ones become opposite. They don't change, they don't move, but they change signs. So let's go ahead and try the first one, or quick note. If the determinant equals 0, then the inverse does not exist. That's an important note, and we'll see that in a problem in a second, and then you'll understand why that it doesn't exist. So first step is to find the determinant. The determinant is the product of the first diagonal, which is 6, minus the product of the second diagonal, which is 4. So the determinant for this one is 2. So then to set up the problem, to find the inverse, we start with 1 over the determinant. So it's going to be 1 over 2 times the changed matrix. There's 2 changes we have to change from the original matrix. The first change is we have to switch that first diagonal. So this guy here is going to get switched. So this is going to become 3 and 2. And then the second diagonal, they don't move, but they change sign. So that's going to become -1 and -4. And then we just have to simplify this. I do want you to multiply that 1/2 in. For this one, you could give me decimals or fractions. If it's a weird fraction, weird decimals, just leave it in fraction form, but I'm going to do decimals for this one. So this is 1.5, -2, -0.5, and 1, and that would be what the inverse of A is. Now, if you wanted to do a quick check over here on the side, we could multiply them together. You don't have to do this, but I just want to show you what we created really does create the inverse. So you would multiply the original times that inverse, and what we should see, since we want them to be inverses, they should cancel each other out. So if we were to do that, 2 times 1.5 is 3, 4 times -0.5 is -2. And then we do first row, second column, that's going to be -4 plus 4. Then we do second row, first column, that's 1.5 minus 1.5. And then that's -2 plus 3 for the last spot. So we do get 1, 0, 0, 1. So you don't have to do that, but I just wanted to show you that it really does create the matrix that cancels out the other matrix. So now if we're looking at B, I want to find the inverse of B. First step is to find the determinant. The determinant is going to be -8 minus -3. Be careful with these negatives. That's going to change the plus to positive. So we get the determinant is -5. So then it's 1 over -5. We're going to call this B -1 because this is matrix B. Times, whoops. We have to do the changes to the matrix. So the first column, we switch the numbers, or first diagonal, we switch the numbers. And the second diagonal, we change the sign. So this will be +1, -3. And then we're just going to multiply that in. Again, these are nice decimals, so I'm just going to leave it as a decimal. We get 0.4, -0.2, 0.6, and -0.8. If you want to leave them as fractions, you can leave them as fractions too. I'm okay with it either way. So that is the inverse of B. All right, just one more to look at finding the inverse of. If I start, again, the first step is always the determinant. That's going to be -24 minus -24, which changes to plus a positive. And we get the determinant is equal to 0. Seem to remember something on the last page about the determinant being 0, but let's just try and set up the problem anyways. We'd have 1 over 0 times the changed matrix, and right away you should see that there's a problem. I cannot put 1 over 0 in a problem that puts 0 on the denominator, so this one does not have an inverse. There's no inverse because the determinant is 0, which makes the denominator 0. So just beware of that. If you end up with a determinant of 0, there's no way to find an inverse that that particular matrix does not have an inverse. All right, we're just going to end on one last type of problem. It's problems that are going to set up an equation for you to solve. So if you look at this guy here, we have these two lines. I didn't talk about this earlier, but what that means when they put it around a matrix, that means that you're finding the determinant. So that is how they could ask you for the determinant. Without saying it in the directions, they can put those flat lines instead of the brackets. And that is asking you to find the determinant. So the first thing we have to do is set this up, finding the determinant. So we would do the first diagonal, which is x times x, you get x squared, minus, make sure you get the signs right here, the second diagonal is 10x, and then that would equal 24. So then this just sets up an algebra equation for you to solve. The next step should be to subtract the 24 to the other side. And then we're factoring. We're looking for factors of negative 24 that make negative 10. And that should be negative 12 and 2. Yeah. So then it's x minus 12 times x plus 2 equals 0. You get x equals 12 or negative 2. And we will keep both answers because both answers really would work if you plugged it back in. They both give you an answer of 24 if you were to find the determinant. All right, there is a couple problems for you to try in ClassKick, and then you have a homework assignment for tonight as well. And again, we're going to do a quizzes tomorrow.